डिफ़ॉल्ट, हाँ सही है वो, डन 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 डन, हाँ डिफ़ॉल्ट. हेलो हेलो हेलो, ना डिफ़ॉल्ट, मेक इट डिफ़ॉल्ट, मेक इट डिफ़ॉल्ट. हेलो 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 हेलो. Hello Rishika, you haven't joined till now. Waiting for you. Rishika, will you be joining or not? Rishika, will you be joining or not? Okay, waiting. It's been 7 minutes now. She hasn't. Okay, she hasn't joined. It's been 7 minutes now. I don't think so. She's going to join. Huh? It's been 15 minutes now. I don't think so she's going to join. How long should I wait? It's been 15 minutes now. She's got a coding class also at 6 o'clock. 6 o'clock she has got a coding class. Mm-hmm. Inform Mama, I'm calling it off. It's been 20 minutes now. Huh? Oh, up to now this 20 minutes is blank. Restream करूं. Okay. Tell her I'm finishing this event, huh? Uh, Hi Rishika, where were you? I thought you'll not join. I was about to end the stream. Okay. You're having an outing today? Okay, now, so we've got very little time now, around 20 minutes left, and 20 minutes. This is a short topic as such. We'll finish it quickly, okay? And this is the last topic of this section. From this, we'll go into satellites and space in the next class, okay? So the topic is power and energy. In the previous class, we had studied what voltage is, right? So Voltage tells us how much energy each coulomb of charge is carrying, right? Greater the voltage, greater is the energy supplied by each ampere of current. Greater the voltage, greater is the charge carried by each coulomb of charge. That coulomb of charge that we studied in the previous class, right? Now today we study what is power and how is it associated with energy. If I talk about power in general term, what is your understanding of power? Suppose two children have to carry something to the second floor, okay, a box to the second floor. One child carries it in 10 seconds, whereas the other takes 20 seconds. The work done by both of them is the same, okay. They have carried it to a height, so there's a gain in potential energy. So now both the boxes have the potential energy equal to the energy spent by the children. Which child has more power? How can you say that? Whatever comes to your mind, okay? Be quick. As per you, which child? The one which has taken the box to the second floor in 10 seconds, or the one who has taken the box to the second floor in 20 seconds? Both took it up to the same height. Okay, one took lesser time, the other took greater time. The work done by both of them is same. Can we say who is more powerful, who has spent more power? Okay, now you see the appliances in the room, right? We have the TV, we have the laundry iron, we have the laptop, okay, and then we have the hair dryer, okay. Now all of them are consuming energy, and all of them are consuming energy at different rates. Okay, some appliances are consuming energy at a greater rate and the others are consuming at a lesser rate. Okay, you see a LED bulb also over there on top of the lady drying her hair. Okay, so now these appliances, they consume energy at a different rate. The one which will consume energy at a greater rate will have a greater power rating, and the one which consume energy at a lesser rate has lesser power rating. Okay, the supply to your house which comes is at a 230 volts. Okay, its voltage is 230 volts, which means that each coulomb of charge carries 230 joules of energy, which can be spent by the appliance which is connected across this potential difference. Okay, now we should let's read what it says. We have already had a look at the picture and we have already listed down the items that are being used where energy is transferred. Okay, and we'll get to know which one is the having the greatest power rating and which one has the least. Before that, we get to know that we have to pay the energy we use has to be paid for. We pay the electricity bill, right? So if we consume more energy, the electricity bill will be higher. Okay, the electricity bill comes in kilowatt hour. The units is kilowatt hour. Okay, so if we consume more energy, the energy consumed in kilowatt hour will be greater and we'll have to pay a greater amount towards the electricity bill. So we can save money on electricity by switching things off when they are not required. Like if we leave a room, we can switch off the AC or the fan and the TV, of course. Okay, then when we don't need them by you and we also can reduce the amount of electricity energy we use by using appliances which are more efficient. We have already discussed about efficiency, so can you quickly tell me what do you mean by efficiency? In the meantime I keep on talking, you have to tell me what have you understood by efficiency in your previous class. Okay, and the other advantage by reducing the amount of electricity we use is that we know that 90% of the electricity is produced in thermal power plants. wherein they use coal, okay, which means a fossil fuel, which means there is lots of production of carbon dioxide, okay, which is let out into the air, leading to global warming and air pollution. So if we reduce the amount of electricity we use, then the load on these thermal power plants also decreases, and less amount of carbon dioxide is produced, thus benefiting the environment also. Okay, waiting for your answer to find out what efficiency means. Okay. Now, as we have already discussed, now we come over here. Okay, some appliances, just a minute. Now, some appliances use more energy. Here, some appliances transfer more energy. Okay, they transfer more energy, whereas the others. Now, the electric oven, which is seen in the picture, it transfers almost 5,000 joules of energy every second. Okay. On the other hand, electric fires, we have discussed these also. Electric fires, hair dryers, kettles, they also transfer a lot of energy, 1000 joules to 2000 joules every second. Okay, and then there are appliances like televisions, the modern LED televisions, okay, which transfer just 400 joules of energy every second. And the light bulbs, okay, the light bulbs, they transfer, and radios, they transfer less than 100 joules of energy every second. So you can see that some appliances are consuming energy or are transferring energy at a much greater rate, right? 5,000 joules per second. On the other, some like the light bulb and the radios, they are not even consuming 1,100 joules of energy every second. Okay, so this means that the power of an electric oven is much greater. Okay, because what is power? Power is the rate at which energy is transferred. More the energy, more is the work done. Okay, so the electric oven and the electric fires, they are transferring energies at a greater rate. We represent power by a capital P. Okay, so the power of these appliances is much higher. On the other hand, the power of appliances like a light bulb or a TV is much lesser, which means the transfer of energy in these appliances is very less. Okay, now let's look at the questions. Let's look at the questions and answer them one by one. Okay, so the first thing which you have to tell me now is, which household appliance transfers the most energy per second? Out of the ones mentioned in the paragraph that we read, which one is transferring energy the most? Which one uses or consumes the most amount of energy? Out of the appliances that we discussed in the previous para, the ones which we saw in the picture, which appliance transfers the most energy per second? Which means which has the greatest power? Power rating of which appliance is the greatest? Waiting for your answer. We've got a coding class also at 6 o'clock. Okay, 6:30. Tell me, beta, which household appliance out of these given on top? The iron, okay. The iron, the electric oven transfers over the now over here. Actually, you're looking into the picture. In the picture, of course, in the picture we have a hair dryer over there, okay, and a hair dryer and electric iron will use similar amount of this energy. Okay, if you look into this paragraph, then the electric oven is using the greatest amount of energy. It's transferring 5,000 joules of energy every second, okay, which is less than a hair dryer or electric fire. Okay, electric fires and electric irons, they use similar amount of energy. So electric oven is the one which is using the highest energy. Then which appliance transfers the least energy? This is pretty simple. I have spoken it twice, thrice. It's written also over here. I had told you it's on top of the lady's head. What's that in the picture? Which one uses the least energy per second? In the picture, I mean, of the appliances given on the top para, which one is using the least amount of energy? Which is one is transferring the least amount of energy? Should I tell? Okay, it's a light bulb. Okay, it's a light bulb. I told you it's on top of the lady's head. She's drying her hair, and on top of her head on the wall, we see a light bulb. Okay, we see a light bulb. So this light bulb is consuming just 100 joules of energy. Okay, if you go back to the picture, you will see on top of the lady head, there you see the bulb. Okay, I'm encircling it. There you see it. Okay, so this bulb is the one appliance which consumes the which transfers the least amount of energy. It just uses 100 joules of energy every second. Then we go to the question, which would save the most money? If I switch off the TV when I leave the room, or if I switch off the light, and you have to explain also, which one will save me more money? Switching off the TV when I leave the room, or switching off the light when you leave the room? Which one will save us more money? Leaving, switching off the TV when we leave the room will save us more money, or switching off the light will save us more money when we leave the room? Which one will save us more money? Waiting. Switching off the TV is the correct answer. And then they ask us the reason also. Okay, so we can see that the television, the TV transfers 400 joules of energy every second. On the other hand, the light bulb is transferring just 100 joules of energy every second. Okay, so if I switch on the TV, I am going to save on almost 4 times more energy, right? I'll be saving 4 times more energy than I save by switching off the light bulb. Okay, so it is advisable that I surely switch off the TV when I leave the room. We go to the fourth one. Which transfers the most energy? Okay, is it a heat energy supplying appliance, or is it an appliance that supplies energy in some other form? For example, a bulb which supplies energy in the form of light, or a fan which supplies energy in the form of mechanical energy, rotating the fan. So which transfers most energy? Okay, appliance that provide heat energy, or appliance that provide energy in some other form? Which transfers the most energy? Which consumes the most energy? A heat producing appliance, or an appliance which transfers energy into some other form? Should I tell you? Okay, I'm going to tell you now. See, appliances which form heat energy. Very nice. No, it's heat energy, but it's heat energy. Okay, just look at the picture again. I'll change the color so that you can relate quickly. Okay, if I look at the picture, if I look at the picture, I see that electric oven over here, electric oven. Okay, it consumes 5,000 joules of energy every second. Electric fly, again producing heat, uses 1,000 joules of energy. A hair dryer uses around 1,500 joules of energy. A kettle uses around 2,000 joules of energy. Okay. On the other hand, a light bulb uses just 100, and a radio uses less than 100. So, so appliances that generate heat, they use a lot of energy. Okay, they use a lot of energy, and my answer will be that the appliances that provide heat energy, the appliances that provide heat energy transfer most energy. Okay, which means their power rating is greater. Okay, which means that they are going to bring a heavy electricity bill. The electricity bill will be heavy if we use these heating appliances. Okay, now you look at this diagram over here. This is printed in most of the appliances, and they tell us whether the appliance is efficient or less efficient. It is more efficient. If I get a green band like this with A rating, which means that my appliance is very efficient. Okay, and it is going to consume very little energy, and the output it is going to give is going to be very high. On the other hand, if appliance has a G rating, okay, which means that it is very less efficient, a lot of electric energy is going to be wasted if I buy this appliance. And generally the appliances which have a poor rating cost less. Okay, which means they are economical in the first place. Okay, they cost less, and the appliances which are more efficient, they cost more. Okay, but in the long run, if I buy a cheap product, if I buy a product which costs me less, then my electricity bill every month is going to be very high, isn't it? And then the generation of this electricity causes to global warming, global environment also gets damaged. So these are, I mean, we should not buy these one just because they are costing us less. We should go in for appliance. We should look into their efficiency. If the efficiency is good, there you see A rating. Okay, this has a A rating, which means it is very efficient. Now we look at the energy. How much energy does this appliance consume? And I see that the energy consumption in kilowatt year per year is 150, which means it uses less than 10 kilowatt hour of energy every month. Okay, it uses 150 kilowatt in a year. I divide it by 12, almost 10 kilowatt hour energy per month. So that's a very efficient appliance. Okay, new appliances have energy labels. This is known as an energy label to show how efficient they are. More efficient appliances usually are more expensive. I've already told you. If the appliance is more efficient, chances are that it will be more expensive as compared to the less efficient appliance. Less efficient appliances are cheap. They are less priced, but ultimately they do a damage to us also by making our electricity bills heavy, and of course they do damage to the environment also, as generation of more electric energy will lead to release of more carbon dioxide, thus leading to more global warming and more air pollution. Okay, that's all in today's class. I had thought that I would do this going green also. Okay, but it's already 5 minutes past 6, and you've got another class at 6:30, I suppose. So I'm so sorry we missed out today because you didn't get the link. In the next class, I'll finish this and then we'll start the next chapter, which is satellites. Right? Thank you very much. Bye bye. See you. Take care.